Okay, it's 5 p.m. on the dot, and I think we can start. Thank you to every one of us that joined in very early. A lot of us were here as 4 and I see our guest speaker.
Hi, good evening, everyone. This is Rola speaking. Please permit us. Jessica's network was, I think, is tripping up, so it's taking her in and out of the call. So very quickly, I'll just welcome everyone once again to today's Fellows Meetup, the July edition of the Fellows Meetup for the month. So welcome everyone for joining, especially those who came in good time, those that were here even before 5. Thank you for your consistency and keeping to time. We are excited about today's session. And very quickly, I'll be handing over to our facilitator. But before we do that, we'll just quickly recognize, I don't know if we have them on the call now, but it's important to acknowledge our partners for this Fellows Meetup. That's GAT Robotics, in persons of Caroline. It was through her that we realized that it was important that we also bring them on board for today's session. So hi, Caroline, if you're there. Hi, good to have you and your team as well. So I'll be handing over now to Kim. Hi, Kim.
Hello.
Hi. So you can share your screen from your end. You have access now.
Okay, let me find the button for that. Where do I do that from? Let's see. Ah, share. There we go. I'm gonna do that one. This one. Okay. Let's see, did that work? Can you guys see my screen now or no?
Yes, we can see it.
We can see it.
Okay, cool. It didn't pop up for me, so I wasn't sure. All right. Cool. Yeah, let's get started. So hi, everybody. My name is Kim Clavin, and today we're going to be talking about designing human-centric robotic systems. So first, I'm going to introduce you to some robots that I've worked on throughout my career, and I'll be using these as examples throughout the presentation. And then we're going to go through some questions that you should ask yourself whenever you go about designing a robotic system and how you can make it human-centric. So first, a quick intro to me. So I've lived my whole life in the United States, grew up on the East Coast in New Jersey, graduated from Carnegie Mellon University with a double major in computer science and robotics. And actually, for most of college, I did not think I was going to do robotics professionally. I thought it was just like a fun class that I would take. And then I would go on and do like a more typical computer science role. So my first couple internships actually were not robotics at all. I worked at AT&T doing some like quality analysis stuff. I worked at Microsoft working on their Windows 10 platform. And then I got an internship at Google X on one of their robotics projects. So that was my first professional robotics experience. And I was like, wow, people would pay me to do this full time. This is amazing. This is what I want to do with my life. So when I was at X, we eventually, the project became known as Everyday Robots. And Everyday Robots, the goal was to create these general purpose learning robots. So it's a very lofty, ambitious goal. We started off by doing some tasks, office building, such as wiping down tables or sorting trash. So yeah, on the left, we have like after lunch, the robot would go and wipe down any crumbs from the table. On the right, the robot would sort the trash into landfill, compost, and recycling. So we're basically just trying to see like, what can these robots do and how general can we make them? We also got to do some more creative projects with that. One of my favorite things that I worked on there was a partnership with our artist in residence to create an interactive robot dance. So I'll play this short clip. So this, we have, this is, we're just trying to see how many robots we could run at once. So it's a little bit chaotic. But all of these robots are running a reinforcement learning model where they're trying to dance according to Katie's movements and her gestures. And it might be a little bit hard to hear in the film because we're laughing, but the robots are also generating their own music. So every time one of their digits moves or like they drive around, it's playing a different instrument and creating this kind of beautiful, beautiful scene. So yeah, so we got to do a bunch of like random cool things like that. The project eventually was shut down, unfortunately, and I moved on to Zipline. So Zipline is a company that does drone delivery, and actually a lot of their initial customers were hospitals and other medical facilities throughout Africa, where the drones would deliver blood, vaccines, and other medical supplies to these areas that were harder to get to. So they are currently operating in Rwanda, Ghana, Kenya, Nigeria, Cote d'Ivoire, Japan, and the US. And they're getting ready to launch commercially their like second version of the drone. So the first version in this clip here, you see the drone just kind of has like a hatch that opens up and the package just has a parachute on it. And we hope that the parachute makes it land gently on the ground and hopefully not break things. But then when I was there, we were working on the platform 2, which is a lot fancier, where you have this thing that they call the droid, which goes down, you load the package into the droid, and then the droid gets retracted back up into the main drone, which they call the zip. And then the zip will go and fly off to the, the drop-off site, where then instead of just like using a parachute to land the item, it actually carefully lowers it on a winch. And then the droid, once it gets to the bottom, just opens up and lets the package out. So it's a lot more controlled, a lot more precise. So when I was at Zipline, we were doing kind of the initial test flights of this new system. And then after Zipline, I went on to Robust AI, which is where I currently work. So Robust AI is a company that's working on collaborative autonomous mobile robots, mostly for warehouse and manufacturing spaces. So this is our robot. We call it Carter. And basically Carter can drive around a space autonomously, but then you can also grab onto that handlebar and then move it around however you want. And it has like an interactive touch screen where it can prompt you on, things it needs you to do to help complete the task. So that's kind of my professional robotics experience. I'm also a mentor for Gator Robotics, which is how I got connected to do the talk today. So Gator Robotics every season has to design, build, and program a robot to compete in a game, and it's a different game every year. So here are some highlights from our last season, where we got to design this really fun shooter mechanism to basically launch these PVC pipes up into the air to try to land on that purple thing and score some points. I also have volunteered with an organization called System Coalition, where we went to a town called Nadire in Zimbabwe, and we ran a coding camp, basically. So we trained a bunch of primary and high school teachers there on computer science and robotics, so that they can now run a coding club at their school. So we brought them these little Finch robots that the kids were able to use and kind of drive around. And that club has been running now for the past 2 years in Nadire, and they've been trying to, spread the teachings to other schools in the area so that they can also run these programs. Okay, so that's kind of the overview about me. We'll come back to a couple of these robots throughout, but now let's dig into your designing your own robotic system. What are some of the questions you should ask yourself? So the first one that you should ask is, who is this human that you're designing for? You want a human-centric system. Who is the human? So I could think of 3 main categories of people that you might want to design for, and all of them require slightly different considerations in the design process. And probably you're going to end up wanting to think about all 3 of these, but yeah, you should probably kind of go through them one by one and see how that influences your design. So you have the user. This is the person who is directly interacting with your robot every single day. So for example, at Robust AI, this is probably the person in the warehouse who is using the robot to assist them with picking inventory. Most robots also have an operator. So at Zipline, this could be the person who is putting the package into the zip, or actually for the first version of the zip, in order to launch it, you have to put it on this giant slingshot thing, and it's really cool. So you have operators who are doing that. And then also most robots will have some bystanders around. So these are the people who aren't directly interacting with your robot, but just kind of share the same space. So for example, in a warehouse, if your robots are being used by pickers, the bystanders could be all of the other people in the warehouse who are trying to do things other than picking, the delivery drivers who are trying to come and pick up the packages and load them onto the truck, the supervisors who are just kind of walking around. Basically, every robot will have some sort of bystander. So we're going to go through each of these 3 and talk about what considerations you should take into account for them. So we'll start with the user. My recommendation is that before you design anything, try to spend as much time as possible with your user. And you want to talk to your user directly. I think a lot of times it's tempting to just talk to the supervisor or the company's head of technological innovation, or somebody other than your direct user. And it's important to listen to those people and make sure they're happy too. But your user is the one who's actually going to be touching your robot day in and day out. They are the ones whose lives you're trying to improve. So their opinion actually matters the most. So you really want to try to talk to them, see what their current workflow is, try to understand their pain points, and see what you can do to make their lives better. And I really think it's important to spend a full day, a full shift with them if they let you, because there's a lot of things that if you just watch someone do a task for 5 minutes, there might be some tedious things that they're doing that don't really stand out because they're not doing it for that long. But once you watch them do it for hours on end, you really see how those like small things add up into like big frustrations over the course of the day. So this process is usually called need finding. So yeah, you talk to your user, you understand their workflows, and you see what can we do to make their lives better. And sometimes you'll be surprised that the most useful thing you can do for your user doesn't end up being this like fancy robotic technology. Like it might not be add an AI LLM agent that can talk to them about their day or something like that. So I'll show a quick video here of how Carter helps pickers in a warehouse. So you'll see the first thing we do is it's showing some information about what item needs to be picked. The person picks it up off the shelf, scans it, places it on the cart, and then hits done, and then the robot drives away. So most roboticists would see this and be like, oh yeah, autonomous driving, like we got to avoid all the obstacles, like that's the really fun, interesting thing to work on. And yes, that is really valuable, but there's also a lot of really little things in here that make the user love the robot. So if we watch this again and we go through it, so the first thing we do is right here, we have this little arrow that pops up on the marquee. And this is telling them, hey, the item you're trying to pick is to the shelf on the left. And you know, that's a very easy thing for the robot to add, a very simple visual cue that cuts the search space in half for the operator. So now they know they don't even need to look at the shelf to their right. They know for sure it's going to be on their left. So you're kind of reducing their mental overhead. You're making their search a lot faster to find the object that they need. They're just kind of speeding up their process just by having that one little indicator. So then if we continue, we see that he picks up the object and then he scans it here. So when we actually spent time with our users and kind of watched their current workflow, we saw that they had these hand scanners where to do that same process we just saw, they would, you know, find the item, scan it with their hand scanner, scan the shelf that they took it from, type in a bunch of things to confirm the quantity that they were grabbing of, okay, I got 4 of them. And they would have to maybe like swipe through a couple different pages on this hand scanner and type in a couple more things. And then they'd have to scan the container that they were trying to put it in and make sure everything matched up. And this whole process took a solid like 10 seconds per pick. So it's one of those, like, if you just watch them do it once, you're like, yeah, 10 seconds, that's not so bad. But when you're doing hundreds of picks a day, you're like, wow, this scanner takes so long to do anything. And you realize how like frustrating it is. So we were able to replace that whole process with just like this one single scan on the robot. And then we show them all of the information that they need on this like nice big touch screen where they can very easily, you know, adjust the quantity or report problems. So we've turned this like 10-second operation into like a 1 or 2 second operation. And again, you might think, yeah, like, you know, 8 seconds, that's not that much. But over the course of an entire shift, it really adds up. And then the last thing we did is you see here, so we have to place the item onto the robot. Before, how they would do this is their hand scanner would tell them, this goes into container 17. And they'd have to look at their cart and go, 5, 10, 15, 16, 17. Oh, okay, it's that one. And they just have to like, you know, do that mental math and kind of guess and then like scan the box to make sure that they were right. So we were able to replace that with these LEDs where the robot just lights up the box that you need. So it really increases the speed and accuracy of the pickers, because now they don't have to do that whole like mental gymnastics of, you know, which box is box 17. They just look and it's like, oh, look, it's the one that's all lit up. So now they can hit done and they can move on. So there's kind of just like a lot of little things that, you know, none of those things were like technically that hard to do. right? Like they're all just kind of these like little UI elements that really add up over time and really make the experience a lot better. So definitely talk to your user. Don't discount things just because, that's not like a cool technological problem. Like put in those little polish pieces that really make the users delighted. Okay, so now we're going to talk about the operator. So operators are usually trying to help ensure that your robot has smooth, safe, efficient operations. And your job as a designer of the system is how can you help them with that? What kind of tools can you give them to ensure that your robot works the best way it can? So this might look like a web or mobile app that you give them, some scripts that they can run, or even designing like a secret override button on the robot somewhere that just like resets it. So you definitely want to talk to your operators, get a sense for what kinds of problems they're dealing with often, and see how can you design tools for them to make them more efficient. So as a little anecdote, so when I was working at Zipline, one of the things I was working on was, we had this brand new platform that we were trying to test for the first time, and we wanted to make sure that we were testing it safely, right? This was new code, new hardware. We weren't sure, we weren't totally sure that everything was going to work correctly. So we had a safety pilot, and we wanted to give them the opportunity to switch the drone between autonomous flight and manual flight. So that way we could start an autonomous test, and if something started going wrong, the safety pilot could take over and safely land the drone. So the safety pilots had a controller that looks something like the one that's on the screen here. And so my task was to, give them a button that'll do the takeover. So, I sat in our office and I talked to some other engineers on the team, and we decided yes, this button over here is not currently being used. Let's use that one. Wrote all the code for, how to do the takeover. And then I went out to our testing facility, grabbed one of the operators and said, hey, I designed this new thing for you. You just have to turn this switch right here. And he just looked at me and he said, that's not going to work. And it turns out that, the safety pilots had very specific training that they had gone through, so that they could kind of develop this muscle memory, because they have to take over in an instant, and be very responsive. And he was just like, that button over there, it just goes against all of the instincts that the operators have built up over time. So we talked through it a bit, and he's like, actually, I think this button over here would be a lot more intuitive, just because of the way the rest of their training works. So it was a great conversation. I was able to go back, change it over to that button. Everyone was happy. We started using this. But it definitely made me realize, if I just had that conversation with the operator at the beginning of the project instead of at the end, I could have saved myself the time of having to redo that mapping. So just like you want to talk to your user before you start designing anything, talk to your operator before you start designing anything. They're going to have, the best insights into what they need in order to do their job. So don't just make assumptions, actually talk to the person. Okay. Then the third group is bystanders. And bystanders can be pretty tricky, because I'm a big believer that the success of your robot can really depend on the goodwill of bystanders. So if your robot is designed in such a way that people just naturally like it, they'll be more willing to help it out. So for example, if your robot is driving around an office space, and let's say somebody's chair is pulled out and is blocking the aisle and the robot can't get around it, if your robot has built up goodwill for bystanders, then they'll see this and say, oh, here, robot, let me push this in so you can get past. And they'll just kind of help out your robot and make its life a lot easier. Versus if you've designed a system that people hate, they might see the robot coming and go, oh no, I don't want to deal with this. And then they'll pull out the chair to purposely block it and kind of sabotage your robot. So you can really make your life a lot easier or a lot harder, depending on how bystanders feel about your robot. So I've definitely seen cases where this goes really well and where it goes really poorly. So when I was at Everyday Robots, we were working on a project where the robot would go around and try to tidy up people's desks. So it would like try to take all the empty cans and bottles off of people's desks. And this was a service that you could sign up for in our office. So we had one person who signed up to get their desk tidied, but their desk neighbor did not. So every day the robot would come and clear this guy's desk while his neighbor sat there being extremely annoyed by everything the robot was doing. Because, you know, the desks were right next to each other, and a lot of times the robot would kind of encroach on the bystander and just get up all in his space. It was also like very noisy, very slow, and just day after day, we came and annoyed this poor person who's just trying to do their job. Till they got to the point where one day they were so fed up, our robot had a nice big red e-stop on it. He hit the emergency stop because he just wanted this thing to go away and stop being in his space. So this was a case where we had done such a poor job of thinking about our bystanders that like he like went out of his way to try to make the robot stop. So you really want to try to avoid that. Times when I've seen this work well, so with the same robot, we were trying to see like, okay, how can we make bystanders like us a little bit more? And we realized that if you design these like little interactions with people, it can be like pretty delightful. So one of the things we did is as the robot is driving around, if it sees someone, it'll like kind of turn and look at them and just give them like a little head nod. And just that like little moment of the robot acknowledging you and being like, I see you, like, I know that you're there. It was just like so delightful. And the first time people saw it, like they were just so excited. And I was really sad I couldn't find a good video of that. But I found a video of something similar we tried to do where when the robot was sorting trash, it did not want you to come and add more trash. So it would look at you and just give you like a little head shake of like, no, like don't interact with me right now. And yeah, there's something just about like the robot making eye contact with you that just like, I don't know, makes you feel seen and makes you be like, oh, okay, like I understand what's happening here. The robot doesn't want me to interact. I'll take a step back. So you can really just try to look for those like little things that you can add that'll make people understand what your robot is doing and just kind of enjoy being around it more. All right, so those are some of the people. The next question you should ask yourself is, what is the environment you're operating in? So, you know, the environment can really dictate how your robot should be interacting with the world. So for example, if you are on a crowded street where there's lots of noise, lots of people, everybody's in a rush, there's like no space to get around, then maybe your robot should be like a little bit pushier, like everybody's kind of trying to elbow their way through. So your robot won't seem as rude if it's trying to do that too. Also, it's a very loud environment. Like if you're trying to use like sounds or something, like people probably aren't going to hear it. So you have to think about like, what are the modes you can use to interact with these people and how can you kind of fit your operations to the norms of the environment. Versus if you're in a mostly empty warehouse and there are these like wide open aisles, then if a robot comes like really up in your space, you're like, whoa, like there's plenty of open space, like, you know, give me my personal bubble a little bit. So you should like be less aggressive and, you know, give people wider berths. Also in a mostly empty warehouse, it might be very quiet. So then, you know, trying to use sound to say, talk to the person could be a lot more effective. One thing I will say about sound though, is you have to be careful about the differences between the environment that you're like developing and testing in versus your actual operating environment. So for the same robot that went around and cleaned people's desks, we had it when it first approached the desk. If it saw you there, it would ask like, hello, can I tidy your desk? And when we were testing this in our area of the office, you know, we picked a volume and we were testing it. And we're like, yeah, this seems totally reasonable. our area was like usually like very noisy. People were having lots of conversations. There's just like a lot of background noise. So we picked a volume that seemed appropriate for that. And then we went over to the other side of the building where there was no noise at all. It was so silent. And then you have a robot just suddenly, hello! And it just like seemed very jarring and way too loud. The robot sounded really aggressive, like it was yelling at you. So that was like a good learning for us of like, you want to be able to adjust for kind of like the ambient sound. So yeah, always be thinking about like, what are the differences between my environment, my test environment, and my actual operating environment? And how can I make sure that, things that seem normal in my test environment, do they also hold up in the actual operating environment? All right, so now we'll talk a little bit about the actual physical design of the robot. So the physical design of the robot implies a lot about its capabilities. So Rodney Brooks is the CTO at Robust, where I work. He's also a professor at MIT and was one of the original creators of the Roomba. So he's been in robotics a really long time, and he has a couple laws of robotics that he has talked about that I am stealing for this. So his first one is that the visual appearance of a robot makes a promise about what it can do and how smart it is. It needs to deliver or slightly over-deliver on that promise, or it will not be accepted. So basically what Rod is saying here is that people are going to look at the form factor of your robot and make assumptions about what it can and can't do. And if the robot is not actually as smart as people think it should be, they'll be like really disappointed and frustrated and not have a good experience with your robot. So if we look at these two examples, so on the left, we have the Helix robot from Figure AI. It's a humanoid robot. And on the right, we have Carter from Robust AI, which kind of just looks like a cart. So if you just look at these two robots without knowing anything else about them, what kind of assumptions do you start making about their capabilities? A lot of people will see the ones on the left, be like, that looks like a human. Therefore, it should be able to do everything a human can do. And they set these sky-high expectations of this robot should be able to walk my dog, it should be able to wash my dishes, it should be able to, lift this heavy thing for me. Their expectations are just to the moon. And then they see it start operating, and they're like, oh, well, why is it so slow? And oh, it can only carry like 5 kilograms? Like, I'm a human, I can carry way more than that. Like, why didn't it understand what I said? Like, so just everything kind of becomes like a disappointment, because like no matter how cool the technology is and how capable this robot is, it just never quite reaches our expectations because we've just set them so high. So you just kind of end up with like, okay, that's like not that cool. Versus with Carter at Robust, a lot of people see it and they're like, is that a robot? Like, I think that's just kind of a cart. Like, I don't know, can it do anything? Is there a motor in there even? So their expectations are very, very low for what the robot can do. So then like every new capability that they find out about is like a pleasant surprise. So they see the robot start moving around autonomously and being able to, gracefully dodge between people. And it's like, oh, wow, like I didn't expect it to be able to do that. So then you just have like a lot more like positive sentiment towards it versus kind of the disappointment of the figure robots. So even though like if you look at it from a pure technology standpoint, like the humanoids are probably a lot more capable, a lot more advanced. It's just like the expectations were set differently. So you kind of have a different feeling towards them. So then next question you should ask is, how do you design robots to be for people? So a lot of times when people talk about robotics and robots, the narrative is all about robots replacing people, robots taking their jobs. It's like, the worker against the robot. And as roboticists, like, we don't want that to be the case. Like, we want people to love our robots and like want to work with them. So you want to try to flip the script and say, how can I design my robot to be for people instead of against it? So Rod has a second law of robotics, which is that when robots and people coexist in the same spaces, the robots must not take away from the people's agency, particularly when the robots are failing, as inevitably they will at times. So what this one is saying is that basically the person always has to be in charge. You have to make sure that your robots are empowering people and not taking away from them. And every single robotic system, no matter how well you design it, will fail at some point. So you also want to think through your failure cases and see like how annoying is it when this robot fails. So if we look at Carter again, one of the things that we're really proud of with this robot is this handlebar that he's grabbing now. So the handlebar is a way for the human to always be in charge. So even if the robot is driving autonomously, as soon as you grab that handlebar, the robot will stop its autonomous driving and let you bring it wherever you want. So yeah, so it's like the human always has the final say in what's happening. And then also you see here at one point, Tristan kind of grabs the side of the robot, not by the handlebar, and he's able to also like redirect it that way. So you'll see like right here, he's grabbing it and just kind of like pulling it towards him and pushing it aside. And when he's doing that, you know, the robot's not like fighting against him. It's not like warning, like, oh no, like, don't touch me. What are you doing? It's trying to work with him to achieve the goal. And then another thing that we really like about this design or this iteration of Carter is that it has good failure cases. So for a lot of robots, one of the worst failure cases is like the battery is completely dead. So for Carter, when the battery dies, we say it defaults to a cart. So even when all of the robotic systems aren't running, it's just a cart. It's as good as any other cart in your warehouse. And you can just push it around manually like you would push around any other cart, and you can probably still do most of your job. So it's like even in the worst case scenario, like it's still like a useful piece of equipment. The previous version of Carter before this one, I liked to say it defaulted to a paperweight, where when the battery died, the wheels locked up and you could not move that thing. It was the most annoying thing ever. You'd have to try to like, you know, put a bunch of extension cords together to try to get the power supply out to wherever it was in the warehouse when it died, or you'd have to be trying to like pull, like drag it along the floor, and it was just like not good. So this was something that like we saw happening in warehouses of like, you know, the battery would sometimes die. And we said, okay, we need to make this failure mode a lot more user friendly. Okay. Yeah, so that's actually the end. So to recap, you want to ask yourself, who is the human you're designing for? What is the environment that your robot is operating in? How can I set expectations for the robot through its physical design? And then how do I think about designing robots to be for people instead of against them? Thank you.
Okay, thank you very much, Kim, for this section. Fellows, please let's give her a round of applause. Let's show our appreciation in the chat. And if you have any questions, you can just raise your hand or you can unmute yourself and ask. Okay, I see a lot of appreciation coming in the chat. Please, if you have any question, you can unmute yourself and ask, or you want to type it out on the chat. Let's do that so that Ms. Kim can attend to our questions. Okay, I think we don't have any question. I'm not seeing anyone. So thank you very much, Kim, for joining us today. This section was really amazing. Now I have to think, okay, if I want to design a robot, I have to think about the user, I have to think about the bypasser, and of course, it's a lot. Thank you very much, Kim. I believe we all learned something today. If you did not learn something, I don't know what else to tell you, but me, I learned a lot today. Thank you very much, Kim. And thank you to the Robotics team as well. I can see Caroline here. So nice to have you guys around and the other team members. It's we've been talking a lot and it's basically email, but it's good to have you here to join us today. Thank you very much. Um, at this point, Ura, please you want to say something to Kim to continue with the fellows? Okay, Ura, can you hear me? I don't know if she can hear me, but that's fine. Lillian, please, can you hear me?
Yes, I can.
Okay, thank you very much. So please, you can go on with the fellows now. Have the
Okay.
floor.
Once again, thank you very much, Kim, for this insightful session. I really enjoyed myself listening to you and especially where the robots were dancing. Okay, thank you very much for being with us today. Yeah, so going over to the July outreaches for the month. Who is excited? My fellows, please make some noise in the chat room. I want to see reactions in the chat room because for these July outreaches, I am very, very, very happy because you guys did me proud. You people did your best, and the best is really glaring because for this month, we're having 19 impactful outreaches. Make some noise. Make some noise. That's a lot. A lot of outreaches for 1 month already. And we had these outreaches conducted across 14 chapters. Outreach programs were held in Nigeria, Zimbabwe, Swaziland, Congo, Namibia, Senegal, Ghana, Burkina Faso. As I'm calling your countries, give yourself a round of applause virtually, actually. Mozambique, Rwanda, Zambia, Malawi, Uganda, Sierra Leone, and Tanzania. So over 1,006 girls were inspired and equipped with STEM knowledge. And then 41 teachers availed themselves during this session. A round of applause for us. So directly we engaged and impacted more than 1,527 students, and we targeted schools, including both government, faith-based, and private institutions across all our chapters in Africa. We also had people that did market invasion. So to that, we have the first outreach for the month, University of Nigeria, Nsukka. They carried out their outreaches and it was a nice one. We can see them on the screen. Looking so, they actually enjoyed themselves during this outreach. Okay, the next one would be Chukwuemeka Odimegwu Ojukwu University of Nigeria. A round of applause for them. A round of applause for them, please. Okay, the next one would be Harare Institute of Technology, Zimbabwe. Harare Institute of Technology, Zimbabwe. They did good. Slide, please. Next slide. Okay, University of Eswatini, Swaziland. And the next chapter is ULPGL chapter Congo. This particular chapter, I don't know how to pronounce your full name. So we'll just leave it at the shortened name. And the next one, okay, I'll try. University Numeric Sheikh Hamidou, Senegal. Okay. And the next chapter is the University of Development Studies, Ghana. We have the Burkina Institute of Technology, Burkina Faso, University of Kigali, Rwanda. Also have Eduardo Mondlane University, Mozambique. There's something peculiar about this particular chapter. It was quite inactive for some time, and they came back with full force. A round of applause for Eduardo Mondlane University, Mozambique. Special shout out to you people. And then the next is the Copperbelt University, Zambia. We also have our own Malawi University of Science and Technology, Malawi. And the next is Federal University of Technology, Akure. My 2025 score has been making me very proud. Really, really, really proud. And so the next is Victoria University, Kampala, Uganda. And the next one, Ahmadu Bello University, Zaria. This chapter is also spectacular. A round of applause for them. And we have Enesbai Koroma University of Science and Technology, Sierra Leone. My 2025 scholars are really making me proud. And the last but not the least is the Muhimbili University of Health and Allied Sciences, Tanzania. Please, a round of applause for all of you who carried out outreaches for this month. Some of us carried out 2 outreaches, others carried out singular outreaches, but all of you are duly recognized. And I am very happy that we turned up in our masses to impact our generation. Thank you very much. And now up next is the chapter of the month. Okay, chapter of the month. Who would it be? Our chapter of the month has not been chosen yet because there was a lot of across all our chapters. A lot of us did so good. Now we are confused on who is going to be the chapter of the month. So we engage you to get the reports coming. We will inform you of the chapter of the month sometime next week, and will be celebrated in the WhatsApp group. And that is that for the chapter of the month. So we'll keep us hanging. So stay tuned for the outstanding chapter of the month of July. All right. Okay, so right now we'll be dropping the link to our feedback in the chat room. Please and please fill up that survey form. We really need it. Really need your feedback. Mind you, it's also part of your assessment for chapter of the month. So if you are here, you didn't fill up the form, we won't know you are here. I don't know everybody that are here, and most of us didn't even go in with our real names. So I can't really say for now that, okay, I have this person in this room, in this call or not. So please, if you are here, fill up the form as we drop the chat, as we drop the link in the chat room. Okay, while that is going on, we'll listen to our reminders and our announcements. As usual, outreach reporting, please don't forget to submit your completed outreaches. It's very, very important, very, very paramount. Please do not forget to fill the outreach proposal form to let us know when next you'll be having an outreach. And after you've carried out the outreach, also let us know that the outreach is done. So please note that the best chapter of the month is usually reviewed and selected based on these submissions as well. So to buttress for all of us who have not taken time to read through our criteria for choosing the chapter of the month, there are 5 key criteria for choosing the chapter of the month. First is the number of outreaches you carry out in a month. Second is if you attended this fellows meetup. Third is how many of your fellows joined you in the meetup as a chapter lead. And the third is if you reported your outreach. The last one, and not the least, is if you filled up this survey form. So that is why we've been hitting on this survey form. So please make sure, do yourself good, do us good, make us all proud, and fill up the form before you leave this meeting. Monthly Fellows Meetup, the next session will be held on Saturday, August 30th at the usual time. Please mark up your calendars and plan to attend. Also get your fellows involved in all of this. So it's just a stamp. Every last Saturday of the month, of every month, is our fellows meetup. So whether we remind you or not, just bear it at the back of your mind that every last Saturday of the month is our fellows meetup. Do not forget to fill out the feedback survey. The feedback survey is this link that has been dropped now. Fill out the survey. It's very important for us. And if you would like to, for some time now, we've not done this, but if you have a striking testimony, outreach story to share with us, you can reach out to me on WhatsApp. So would feature you in the next edition of the chapter engagement highlights. So please reach out to me on WhatsApp. I'll listen to your story and we'll give you the floor to share with others what your outreach stories. Okay, having come to that, we still have 8 more minutes to end the meeting. So let's quickly go over and fill up the survey form. And as we do that, let's all bear in mind that WAAW Foundation is here for us, and we're here for WAAW Foundation. There is no us without you, and there is no you without us. So please, do good. Make sure to impact lives in the little way you can, and make yourself proud first off, and then make all of us at WAAW Foundation very proud. Thank you. And remember, together we keep achieving great things. Thank you, everyone, for joining this meeting.
Thank you very much, Lillian. Thank you, Lillian. And thank you very much to our fellows. Wow, I was looking at these outreaches and I'm like, damn, our fellows are really doing a lot. Like 19 outreaches or more in 1 month. And then some people were complaining, this month schools are closing and all of that. And trust WAAW fellows to do their best. Oh my God. And I'm seeing a lot of new chapters. And I'm like, when did this chapter join us? When did this chapter join us? But believe me, you guys are doing amazing. Thank you very much for joining us today. We'll meet again, same time, not same day, but of course, it's going to be the last Saturday of the month. And before we leave, please let's take our group pictures. Please turn on your video. Let's take our group pictures. Let's see our beautiful faces, please. Please turn on your video. Yeah, I can see Chimdindu. I can see Ona Ebere Chupu. Of course, I can see Miss Kim. I can see Miss Caroline. Oh, I can see Mirel. Please turn on your video. Let me see your beautiful faces. Sorry, it's already dark in my end though. That's my own faces. Okay. Okay, nice shots taken. So thank you very much, everyone. Thank you to the GAT Robotics team for joining us today. Thank you to Caroline and to our guest mentor, Kim. And thank you to the WAAW Foundation team. I have Rura and Lillian on the call, and Timmy as well, our executive director. Thank you to the fellows. Without our fellows, we won't be having this fellows meetup. So thank you all for joining us today. We'll see you again next time. Bye.